So in 4.1, we were factoring using the greatest common factor, or the GCF. We have another method of factoring, and it's called difference of two squares. Now, the cool thing about difference of two squares is that it's a special case in our factoring. So we're learning it first so that you can recognize it right off the bat. Difference of two squares is pretty nice, okay, and it's pretty easy to recognize. So what does the difference of two squares look like? This isn't written out in general terms. This is the rule, which is why I made it super big. You need to make sure that you put a box around it, write it really big, put stars something. Okay, but difference of two squares, this is our rule. A and B are letters that stand for terms. We just don't know what they are yet. So if you have A squared minus B squared, this is where we get the term difference of two squares. Minus means difference, right? And how many squares are we subtracting? Two of them. Both terms must be perfect squares. They must be being subtracted. And here is our rule. We take the square root of A squared, or A, add it to B, and then we multiply A minus B. So we just take the square root of each one. One is being added, one is being subtracted. We will see why this works when we check our answer. What is your first step? You must always check for a GCF first. Anytime you factor from now until the end, you will always check for a GCF first. It's a lot easier to do problems if you know what the GCF is first. Example 1.
What?
X squared minus 36. First thing we want to look for, is there a GCF? Look at this really quick. Do you see a greatest common factor in here?
Yes.
What do you think it is? 36? Does x squared have a 36 in it?
No, it can be 6.
X squared is just x times x, and does 36 have any x's in it?
Yes. No.
No. So there's no GCF, right? Okay, there is no GCF in here. Okay, so the next thing we need to check for is, are these perfect squares? Is x squared a perfect square?
No. Oh, yes.
Yeah, it is. Is 36 a perfect square?
No.
Yeah.
You know this?
Yes.
6 squares.
So, are both these perfect squares?
Yes.
The answer is yes. Are they being subtracted?
No.
Yes, they are. So, we're going to apply this rule. How do we apply the rule? What is my A term here? X, right? This is the same as saying x in parentheses, all of that squared, right?
Oh, because that's an invisible one.
Minus. How can we write 36 so that it looks like this? How can we write 36 so it's a number squared? 6 squared. So now we have it broken down into A squared minus B squared, yes?
No.
Make sense? What I'm doing? So what's the A term here? X. What's the B term? 6. So how do we apply the rule? What I do is I always draw my two sets of parentheses first, and before I fill anything in, I fill in the plus and I fill in the minus. That's my rule, right? They're being added, multiplied by two of them being subtracted. In my first spot is the A term. What's the A term? X. So we just fill in X. What's the B term? 6. So we just fill in 6. That's your answer. This is factored. That's all you do. That's the answer.
So we can't say like yes and no whether or not it's a difference or...
How would I check that I factored this correctly? Does anybody have any guesses? What would I plug in though? How would I check that this is correct? Who said that? Ellen, you do FOIL or method. What is it that we actually did here? We just broke it apart, right? To check if our answer is correct, let's put it back together. So we would use FOIL here. So x times x gives me x squared. X times negative 6, negative 6x. Positive 6 times x, positive 6x. And positive 6 times negative 6, negative 36. We need to combine like terms. Look what we have. Negative 6 plus negative 6x plus 6x. What happens there? 0. Which is why we make 1 a plus and 1 a minus. Because then they're going to cancel each other out. So what would I be left with? X squared minus 36. Is that what I started with? Yep. So I factored it correctly. That's all factoring is, guys. We're breaking it apart. What we did in the last unit was we were putting it all together. So we're just going backwards this time. Okay, example 2.
I agree with Carlos.
Right, let's look at 100 minus y squared. Is this a difference of 2 squares? Look at it carefully. Are these both perfect squares? Is 100 a perfect square?
Yes.
Yes, what is it?
10 times 10.
10 times 10, or that's the same as saying what? 10 squared. So I like to write it so that you can see what it is squared, because that's going to make it easier for us to apply the rule. What about y squared? Is that a perfect square?
Yes.
Yeah, it is. It's what? Y times y, which is y squared. So is this a difference of 2 squares?
Yes.
Yes, it is. So let's apply the rule. First thing I do is I set up my parentheses. 1 is a plus and 1 is a minus. And what goes in this first spot here? What's the square root of 10 squared? 10.
And then y.
And what goes in the second spot? Y. Very good.
So is that basically what we're doing?
That's what we're doing. The cool thing about difference of 2 squares is it's a rule, and we apply the rule.
I thought you said this.
Okay, I get this now.
Oh my God, it's one of mine.
Okay?
Oh my God.
So first thing, good. We always are looking for greatest common factor first. Do these guys have a greatest common factor? I don't see anything, because I'm just thinking in my head, we have 4x squared. 4 breaks down to 2 times 2. 9 breaks down to 3 times 3. So there's nothing in common there, right?
No.
Okay, so how would we rewrite 4x squared as a perfect square? Bobby, do you know?
2x. Right?
2x in parentheses, right? All of that squared. Minus what?
3y.
3y in parentheses. You cannot forget the parentheses.
Because then you'll be doing y.
Because then you'll only be squaring y and not the 3. So 3y squared. Is this a difference of 2 squares? Yes, it is. So the first thing I do is I fill out my parentheses. 1 is plus, 1 is minus. What goes in this first spot here?
2x.
Very good, 2x. So you guys got this.
3y.
What goes in the second spot?
3y.
Excellent, 3y.
Will you ever get,
How do I check it? Good, you FOIL.
will you ever get, like, 4x squared and then yx?
Exactly what I was talking about. X squared plus 9. Is this a difference of 2 squares?